Today, we're going to pull back the curtain on one of the most important shortcuts in all of artificial intelligence. It's the secret to how AI systems learn about the world at a massive, almost unbelievable scale.
So, let's start by tackling a really common misconception. Most people think that for an AI to learn that, say, Elon Musk found at SpaceX, a person has to find a sentence somewhere and manually tag it like, "Hey AI, this sentence right here shows a founder relationship."
But can you imagine if we had to do that for every single fact in the world? We'd literally never get anywhere. On the left, you see the old way. It's slow, it's expensive, and it just doesn't scale. But on the right, that's the cheap trick we're going to break down. A way to automatically label billions of sentences without a human ever having to read them.
To really understand why this trick is so important, we first have to appreciate the huge problem it solves, and that is the human data bottleneck. The truth is, modern AI is just incredibly data hungry. It needs a staggering amount of information. If we were still relying on humans to spoon-feed it every single piece of information, the entire field would have ground to a halt years ago. There just aren't enough people or enough hours in the day. We absolutely needed a way to break through that limit.
And the solution came in the form of a brilliant, kind of simple mental model. Let's call it the phone book trick. It's an analogy that makes this whole complex process feel really intuitive.
First things first, you need a phone book. In the AI world, this is called a knowledge base. Don't let the name scare you. Just think of it as a simple database of facts we already know are true. It's the AI's cheat sheet.
Okay, so here's how the trick works. Imagine you have this phone book and a massive library full of completely unlabeled books. Step 1, you pick a name from your phone book, say John Smith. Step 2, you search the entire library for any mention of John Smith. Every time you find his name, you automatically stamp back page with his address from the phone book. You haven't read the page, you've just labeled it. Now, step 3, just repeat that process millions of times for every single name in the phone book. All of a sudden, you've labeled a massive library with almost no human effort.
All right, that's the analogy. Let's move from the phone book to a real, concrete example and see how an AI actually uses this method to learn a real-world fact.
So the AI starts with its cheat sheet, that knowledge base, and let's say it contains just one known fact. The relation is founder, entity 1 is SpaceX, and entity 2 is Elon Musk. The AI knows this single relationship is 100% true. Now, just like our library example, the AI goes out and searches a massive body of text, think of it as the entire internet, for every single sentence where the words SpaceX and Elon Musk appear together in any context at all. And this is what it finds: a huge, really messy list of raw, unlabeled sentences. You get things like, Musk started SpaceX in 2002, or SpaceX founded by pioneer Elon Musk, and even stuff like Elon Musk flew on a SpaceX rocket. At this point, they're all just random strings of text.
And this is the magic trick. The AI takes its one known fact from the cheat sheet and automatically stamps every single one of these sentences with the founder label. It's basically assuming that if both names are present, the sentence must be expressing that founder relationship. After doing this millions of times, it starts to see patterns. It learns that sentences we've now labeled founder very often contain words like started, established, or co-founder of. It's learning the patterns of a relationship, and a human was never involved.
Now, I know what you're probably thinking. Wait a minute, that sounds incredibly messy. What happens when the labels are just plain wrong? And that is a great question. It gets right to the heart of this whole thing. This messiness actually has a name. It's called noise. Noise is what happens when the AI finds a sentence like, Elon Musk flew a SpaceX rocket. Both names are there, so it gets the founder label, but the sentence isn't actually talking about the founding of the company. That's an incorrect label. That is noise. So why on earth does this still work? The answer is sheer brute force volume. The AI might see that incorrect flew a rocket pattern, say 10 times, but it's going to see the correct patterns, the ones with words like started and established, 10,000 times. At that scale, the correct signal becomes overwhelmingly clear, and all that noise just fades into the background. It becomes statistically irrelevant. The method values volume over perfect precision. Let's just pause and think about this for a second. Imagine you have a database of your company's product repairs. That's your cheat sheet, right? Could you use that database to automatically scan and label thousands of incoming customer emails to figure out if they're about broken screens or battery issues, all without a person reading them? The answer is absolutely yes. So this cheap trick, this powerful idea,
It actually has a formal name, and it's the secret engine behind many of the AI tools that you probably use every single day, especially search.
The formal term, which came out of Stanford, is distant supervision. And it's called that because the supervision, the labeling, is coming from a distant database, not from a human looking directly at the text. It's using a source of truth to automatically supervise the learning process from afar.
And the impact was just massive. As a Stanford lecturer on the topic explains, this one idea allowed researchers to suddenly use 100 times more data than ever before. It completely shattered that data bottleneck we talked about at the beginning.
And this is not just some academic concept. The idea was developed at Stanford around 2005. By 2010, it became a foundational piece of Google's knowledge graph. That's the info box that pops up on the side of your search results. And by 2017, it was being used to help power Apple's Siri, helping it understand facts about the world.
So, let's just recap the big takeaways here. Number 1, distant supervision is a shortcut that uses existing databases to automatically label huge amounts of text. Number 2, it works because it values volume over precision, using enormous scale to find the real signal and just ignore the noise. And finally, this is how major AI systems build the giant knowledge graphs that power the tools we use all the time, like Google Search and Siri.
And now you can actually answer a pretty common question. You know when an AI states a fact with total confidence, but the phrasing it uses sounds just a little weird or unnatural? Well, it's because it probably learned that fact through distant supervision and picked up some of those noisy or just accidental word patterns from its massive unedited training data.
So, we've seen how AI can gather billions of facts about the world. But that leads to the next big question, doesn't it? Once it has all these facts, how does it actually reason with them to understand language? We'll dive into that next time.